Let me begin by saying a few words about traditional gauging, specifically with reference to how mastering is done. What has to be kept in mind is that when you master with a traditional N gauge, you're mastering relative to a specific dimension. For example, let's take the N. In this gauge, which has an N bushing on it now, and that N male bushing would have to be swapped for a female when doing the female. But in this case, with the N bushing on it, to master the gauge, you're going to be seating the gauge so that the contact point resides within a bored hole, and that bored hole has a depth of 210 mils to match mil C 39012, the standard. So the way mastering gets done is to seat the gauge in such a way that the contact point resides within that bored hole, and then you rotate the bezel so that the zero on the face of the indicator lines up with the hand. You just unloosen the clamp and turn the bezel. But the punchline here is that with traditional gauging, that bored hole can vary, and you accept on faith that it's 210, but if you actually measure the bored hole with a Mitutoyo caliper that's twice as accurate as the tolerance on the gauge, you get 211, 211, 211. And of course, the Mitutoyo has a tolerance itself, but again, it's twice as good as the tolerance on the gauge. So on the assumption that you're closer to 211 than 210, the first problem we have with traditional mastering is that we don't like the fact that you have to master relative to a bored hole, which is a lot harder to machine than a flat surface. And we don't like the fact that every time you change standard, you have to change master gauge. So that, for example, the three most common standards for male recession relative to the shoulder of the shoulder of the male pin and the reference plane are 208, 210, and 207. So in this case, we're looking at 210, which looks like it's more 211 than 210. But if we go to a standard like IEEE 287, where the difference in where the displacement of male shoulder relative to reference plane is 207 mils, we now need a master gauge that's bored to a depth of 207 mils. If it's another standard, it could be bored to a depth of 208 mils. So the bottom line here is that for true universal gauging within the Type N family, you need at least 3 master gauges, and you also have to check the tolerance on that bored hole, which again is harder to machine than a flat surface and also tends to collect debris, which makes it difficult to clean. And what I'll show you next is how we've departed from that traditional scenario, where we've machined the bushing in such a way that when we do our mastering, we are mastering relative to all standards, and we're mastering relative to a flat surface. And I'll show you that next.